Hey everyone, first of all, I just wanted to apologize. I know it's been a long time since my previous video. As you may or may not know, Melbourne has gone back into the lockdown for the second time. So it's really hard for me to go to a friend's place to film any sort of interview or podcast. So today I thought we'll do something slightly different. So what we're going to do today is a little bit of coding session. So I'll walk you guys through the notebook on a project that I've been working on for the past 2.5, 3 weeks. But before we get into the notebook, just wanted to let you guys know where you can find this project, this case study. So it's on a website called InsideSherpa. So you can head on to the website InsideSherpa.com. And what InsideSherpa is I think they're a startup, and they've partnered up with a lot of big name companies around the world. So like BCG, Citigroup. But the one that I'll be going through today is with a company called Quantium. Data Analytics Virtual Experience Program. So this is what we're going to do. So if you've read one of my Medium articles, I've actually mentioned Quantium before. So Quantium is a data science, artificial intelligence company here in Australia, and they work with large corporations, businesses, and governments, and they help them extract actionable insights from their data. And using those insights, how can they further improve, their efficiency, their business performance, etc. So Quantium is actually one of the companies that I'm really interested in, and it's one of the big reasons I've embarked on my journey to learn more about data science and machine learning. So I was really excited when they partnered up with InsideSherpa to come up with this program. So this is what we're going to go through today. So you can have a look through the program yourself in your own time. So essentially what it is there's going to be 3 modules. The one that we'll be focusing on in this notebook is module 1. So you can go to the virtual experience program, and then from there you can see there's there's prompts, there's videos for you to watch. But what we're going to do today is data preparation and customer analytics. That's what we're going to do today. So click on that. So there's actually like there's a whole lot of reading which you can do if you're interested in your own time. But I'm going to save you some time, and I'm just going to summarize for you what we're going to do. So essentially, this module 1 is based on a case study. So you're acting as a data analyst and you're consulting a retail store. And more specifically, you're consulting a category, I think that's what it's called, category manager of a retail store. So a retail store in Australia, you can imagine being, something like a Coles or Woolies or Aldi. So the category that we're focusing on specifically in this module is chips. So we're only looking at chips. So you can imagine like a retail store would have a bunch of different items that they sell. But however, in this module, we're just only looking at chips. So the task is, so you're given 2 sets of data. So one is the transaction data, and then purchase behavior, which is, I think, like a customer profile. So using these 2 data sets, how can you extract insights from customer, whether that is purchase behavior, whether that is looking at which products are the most popular, which customer segment drives the most sales, etc. So this is where you would download the data. So you've got 1 data set, 2 data sets, and you also get a solution template, which is in R. But I'm not going to do my analysis in R. So what I've done is actually in Python. But if you prefer doing your analysis using R, feel free. But what we're going to do today is go through a notebook, which I've done using Python. All right, so I think I've said what I needed to say. So let's move on to the notebook itself. All right, let's start. So, by the way, I'll be posting, so you have access to this notebook on my GitHub. I'm going to post it on my GitHub. I might put it in the description of this video. But anyway, if you want to look up my GitHub, my name is chongjason914, and then it should be under chip sales. I know it says private at the moment, but you'll have access to it by the time you watch this video. All right, so without further ado, let's walk through it. So the first cell that I've done here is include a bunch of libraries that we're going to use throughout this notebook. So stuff like data analysis and wrangling. We're going to use Pandas. So Pandas is a big data manipulation tools. Any event that you're working with a big sort of data frame or any sort of data frame for that matter, Pandas is a great tool, especially if you're using Python. And then we have NumPy. Visualization-wise, we have Seaborn. So Seaborn is another great tool if you want to create beautiful color, nice-looking graphs. Seaborn's a great tool for you to use. And then Matplotlib, missing number, which we'll see a little bit later. And then the rest you can go through it yourself. So it's essentially just dates, text analysis, and a bunch of stuff for statistical tests. And we're going to remove all of the warnings. So while this runs, so this is actually on Jupyter Notebook. So if you want to work using Jupyter Notebook, you can Google Anaconda. So Anaconda should contain Jupyter in one of the programs. So Anaconda is like this big navigator, and Jupyter Notebook is one of the features. So all you have to do is just head on to Google, search for Anaconda, download it, and Jupyter should be there. All right, and that should be loaded. And in case you're new to Jupyter Notebook, the way you run a cell is via Control-Enter or Shift-Enter. All right, now that we've run our libraries, our next step is to load our dataset. So recall from the page, we're given two datasets. One is QVI transaction data and then QVI purchase behavior. So what I've done here is just to load those two datasets into what I call customer data and transaction data. So let me just go ahead and run that. All right, so that has been loaded. Oh no, it's still loading. All right, that's loaded. And all right, let's start off with transaction data. So let's look at the first 5 rows. So the way you do that is you use .head and you just do Control-Enter. So it's always a good practice every single time you're doing a piece of analysis, and especially true when you're doing exploratory analysis, which is usually the initial stage of a data science project. So it's always a good practice to just look at the first 5 rows, or first 10 rows for that matter, and go through every single column to just get a better sense of the data and see what the variables are, so that you can have a better understanding going in, and that can drive your sort of analysis further on. So let's look at the individual columns. So we have date, which is kind of not in the right format, but we'll get to that later. We have store number, loyalty card number, TXLAN underscore IDs. So this is maybe this particular store have sort of categorized their transaction based on IDs. So every single transaction has a unique transaction ID attached to it. And then we have product number and product name. So these two should be unique to each other. So you can imagine a retail store like Kohl's would have a whole bunch of products that they sell. So they've assigned a product number to every single product name. So this should be a unique pair. And what I mean by that is every single time a customer makes a transaction for, for example, Natural Chip Company sea salt 175 grams, that should have product number 5 attached to it. So they're unique to each other. And then we have the last 2 columns, which are product quantity. So how many packets of this particular brand of chips they bought in that transaction, as well as the total sales, so how much they spent in that single transaction. All right, so that's what we're working with in terms of transaction data. Let's look at how big our data set is. So the way you do that is you use .shape. It's a function. So you just run that, Control-Enter. So this tells us the number of rows and the number of columns. So we have here about 264,000 rows and then 8 columns. So if you count from date all the way to the end of total sales, you'll have 8 columns. An alternative way you can do this is, say you want to only look at the rows of the data. So the way you do that is you put a function called len, L-E-N, open bracket, and then close bracket this, Control-Enter. So this tells you the rows of the data set. All right, what I've done here is n unique. So this command tells us the number of unique transaction IDs there is in the data. So let's run this. So as we can see here, we only have about 263,000, which is less than the length of the transaction data. And a possible reason for this is every single row is not, it's not a unique transaction, meaning every single row represents a transaction for a single brand of chips. So a customer could potentially buy, maybe 2 to 3 brands of chips in a single transaction. and hence it'll show up as it'll have the same transaction ID, but it'll show up as different rows in that data. So just to give an example, so let's look at any duplicated transaction IDs in the row. So the way we do that is there's a function called duplicated, and I've passed in transaction IDs. So I want to look at, for every single row, what duplicated transaction IDs are there. So let's look at the first 5 duplicated values. So we've got a bunch of duplicates, and let's just take the first row, for example. Let's look at transaction ID 48887, and we want to see that particular transaction, what brand of chips this customer has bought. And the way we do that is we use a function called loc or location. So location is a pandas feature, which you can think of it as like a GPS. So it takes in 2 arguments. It takes in an argument followed by a comma and then a second argument. So what this is saying is, so the first argument represents the rows. So what I'm doing here is give me the rows that have transaction ID equals to this number, and show me all the columns of these rows. So, so if we run this, we can see that there's 2 rows with the exact same transaction IDs, and this shows the entire data set because we want all the columns. Okay, and so as we can see here, these 2 are similar transactions. So they're one single transaction, and they're made in the exact same store as we would expect, and it's coming from the exact same customer. So this customer has bought Dorito corn chips and twisty chickens in one single transaction, and that has shown up in 2 separate rows. All right, so now that we've got a better sense of the data, let's move on. .info tells us the data type of the columns. So date here is int 64 and so on. Product name is an object because it's a string of characters, and so on. You can have a look through that. And the next thing we're going to do is missing no dot matrix. So this is something has been very useful that I found, I think, watching a YouTube video or somewhere on Kaggle. I've been using this quite extensively every single time I'm dealing with a new data set. So what this does is it'll show you the missing values in a given data set. So what you have to do is you pass in your data set, and it'll return something that looks like this. So let me just run through this and then we can explain. So we have all 8 columns of our data, and every single time there's a missing data, it'll show up as a white line. So judging from this, we can't see any null values, so which is good. So let's move on to the individual features and explore them one by one. All right, let's start off with date first. So as mentioned at the very beginning, our dates don't look right? So we have to do something about it so that's easier for us to read. So as it turns out, the date that we see in the data set, it's in a format called like an Excel integer format. So what I've done here is define a function that takes in dates in that format, run through a bunch of code, and then that function is going to spit out at the end a converted date, which is something that we're more familiar with. Something that's in the format of year, month, and day. So if you're familiar with Python, this is the way you would define a function. So you would use something called a def, and then the name of the function, and then you want to specify the parameters that you're going to put into that function. So we're just going to run this function. And then what we're going to do next is we're going to take the date column and then apply this function to it. And let's look at our new edited date. All right, so as we can see here, our date is in a much nicer format. So we have 2018, October 17, and so on. So now it's in a lot nicer format. So we can have a look at the whole data set altogether. All right, so as we can see here, our date is in the right format, and the rest is just the same. And so now we're going to move on to product name. So product name is, we have that particular brand of chips, and then we can see that it seems to always end with the weight of that single product. So what I've done here is created a new column called pack size, and I've extracted the numbers out of the product name. So what I mean by that is, so for example, this first row, we have Natural Chip Company Sea Salt 175. So what I've done here is just extract the 175 and put it in to a new column called pack size. So you can see here, this column has 175, and then 175, 170, 175, 150. So yeah, so that's pretty much just what I did. So I just took the numbers out of it and then put it in to a new column called pack size. And then we're gonna move on to what did I do here? So I created a text cleaning function for product name feature. So as we can see here, we have some special characters like a backslash and a and symbol. So what we're gonna do is we're gonna remove these special characters, as well as we're gonna remove the product names because we've already taken them out and put it into a new column, so we don't need that anymore in the product name column. So what I'm gonna do here is, again, use def, which is create a new function called clean text. And through that function, it's gonna remove the special characters as well as remove the product names. So once we create that function, we're gonna apply that function to product name. All right, and what we're gonna do next here is look at the product names and see which words come up the most often. So the most frequent words that show up in that particular column. I'm not going to go through this. You can go through this in your own time. So the result of that, you're going to get something like this. So we're going to see chips as the word that's most frequent, as it would make sense because we're looking at the chips data. So chips would make sense as one of the top words that will show up, followed by Kettle, Smiths. These are all brands of the chips, and then the rest. And what I'm going to do here next is remove, drop the rows with salsa in the product name. Because we're only concerned with chips, we're going to remove salsa. So I didn't come up with this particular idea, so I was just following the sample solution template that I was given in the module, and I was told to remove the salsa. This is what I did here. So if I run this, and then let's look at our transaction data. All right, so cool. So product name, we've removed the product weights, as well as any special characters that is present in the product name before. All right, cool. So let's move on to product quantity and total sales. So let's look at product quantity. So this is the number of packets that a customer buys. And value counts tells us how many times that pack has shown up throughout the dataset. So we can see here 2 is the most frequent, followed by 1, 5, 3, 4. Wait, what's this? 200 packets. And this has shown up 2 times in the entire dataset. Which looks a little bit odd. Can you remember the last time you bought 200 packets of chips? Because I don't. So let's have a closer look at this 200. It seems to be like an outlier. And if it is an outlier, we're gonna have to remove that to prevent skewness in our data when we do our analysis further on. So let's look at product quantity that is equals to 200. So again, we're using loc, the loc function. So show me all the rows that has 200 in its product quantity, and I want to see all the columns. So I hit Control Enter. So this is what we have. So let's have a closer look. So they have the same store number. It's coming from the same customer, and yeah, so the rest is pretty much, it's also the same product. And then this customer has bought 200 packets 2 times throughout the entire year. So let's look at whether or not this customer has made any other purchases throughout this year. So again, using loc, and tell me, show me the rows that has his or her loyalty card number. So this is it. So as it turns out, this 2 is the only transaction that this person has made in the entire year. So I've left a comment here and said that this person has only made 2 transactions over the entire year. So he or she is unlikely to be a retail customer. So it's safe for us to drop these 2 rows from the data set. So what I did here was just to drop the rows from the data set. So both the transaction data and the customer data. So Control Enter. And this next cell is just to make sure that we've dropped it. All right, so it doesn't show us anything, which means the row has been dropped. Let's move back to looking at dates. So now that we've changed the dates into a nicer format, let's look at the number of unique dates. So as we can see here, there's only 364, but there's 365 days out of the entire year, which means that we have one day that is missing. So what I've done here is I create a date range that starts from 1st of July and ends at June 30th the next year. And then I passed in the date, and using the function called difference, this will tell us the missing date that is in between these two dates. So if I run this, it should tell us the missing date here is 2018 December 25th, which is Christmas. So it makes sense that we don't have any sales registered for that name, because for Christmas most retail stores will be closed, and it will make sense for us to not see any sales present in the dataset. And what I've done here next, you can go through it. I'm not going to go through it with you. So essentially what this is I'm just creating a new data frame, and then I've plotted a new graph using that new data frame. So this is what we're going to see. I'm just going to discuss and talk about the graph itself. You can go through it during your own time, how to create a data frame and then how to plot it. So what we can see here is the total sales that starts from July 2018 and ends June 2019. So what we can see here is sales, and then we can see this spike going up here around about the December month, and then we have this drastic drop here, which is almost towards the end of December, which tells us from before that it should be from the Christmas day. So a retail store, you can expect to see something that is quite typical like this. So you have sales that is doing this, and then come the December mark, it'll come up, spike up, and then come back down. So this is typical in sort of a retail setting. I remember doing a case study once in an on-site interview with Quantium actually, but the product that we were looking at was soft drinks. So it had the similar feature where it spiked up during the December month, except that but what's different was around the June July mark, the sales kind of dip, which makes sense for soft drinks because June July here in Australia, it's like winter, so it's cold, so people would buy less soft drinks, hence we will see some of the dip. But for most products, we would tend to see something like this. So the sales will spike up in December because it's a family gathering, it's Christmas. People tend to buy more like chips for the whole family to eat. So we typically see this. So this is a zoom in version of the total sales. So this graph only looks at the December. So this confirms that Christmas Day we have 0 sales. So see how we have this V-shaped looking graph here. So you can go through that in your own time. I'm not going to go through it. And this is another, I was just playing around with Seaborn. So this is a bar plot version. So again, 25th, we have 0 sales. All right, so now that we're satisfied with the dates, let's move on to pack size. So again, we're going to look at pack size. And so I'm going to use the function called unique. And this is going to tell me what are the unique pack sizes are there in the dataset. So we can see here 175, 170, all the way down to 70. So I've plotted a histogram to see the frequency and the distribution of the pack size. So we can see here the frequency is the highest around the about 175 mark, and then it slowly flattens out as we go through the both extremes. So the smaller pack sizes is less, and then we have the extreme 350, which is also less than the middle. All right, and what we're going to do here next is again create a new column or feature called brand. So we're going to go through product name, and what I've done here is I just took out the first word of the product name. So in this case will be for the first row it will be natural, followed by CCS, followed by Smiths. So essentially what this is I'm using something called a partition. So a partition breaks down, say, okay, let's look at this. So we have entire string. So a partition would break down this entire string into individual words. So it would be like natural, chips, company, and sea salt. So I've assigned that to be part, and using part 0, meaning I take the first word of that product name, and then put it into a new column. All right, so these are the unique brands in our data set. So if you look closely, there's a couple of brands that have similar names. They're just given different names. So an example of that is SNBTS and Sunbites. Those are essentially the same product. What else do we have? We have something like Doritos. So Doritos and Dorito, that's kind of the same thing. So what I did here next is go through all the different brands and replace the stuff that is similar to a consistent name, so that it's consistent throughout the entire dataset. So I'm just going to run this. All right, so this looks a lot better. So these are all brands that has been cleaned up, and there's no like duplicates or anything. So which brands has the most sales? So what I've done here is using the group by function passed in. So I'm telling Pandas, use transaction data, group by the brand, and sum up all the total sales. And then I want you to sort the values from highest to lowest. So the way you do that is by doing this, ascending equals to false. Control Enter. All right, so these are the brands going from highest sales all the way down to the lowest. So as we can see here, cattle has the highest sales and burger has the lowest. All right, so that is all for our transaction data. Let's move on to customer data. So customer data dot head. So this shows us the first 5 rows of our customer data. So as we can see here, we only have 3 columns in this data set. The first one is loyalty card number, which we've seen before in the transaction data. So this tells us the customer itself. And then we have a life stage and a premium customer. So I'm guessing life stage is it's dependent on like age. So meaning if a customer has it's maybe age 65 plus, we will call them a retiree, and then and so on and so forth. And then we have something called a premium customer, which is dependent on maybe their purchasing behavior. Maybe they tend to buy more expensive products. We will call them premium. Mainstream and budgets maybe are those that have less willingness to spend, and they tend to buy more budget items. So retail stores tend to do this sort of practices. So every single time, say you want to sign up for like a loyalty card, you have to fill in your details. And from those details, retail stores would kind of categorize you so that you are put into, this is what we call like a customer segmentation. So we want to segment customers into groups. And within those groups, you would expect to see similar sort of purchase behaviors. The stuff they buy would be similar. So say, for example, let's say like a young family would over-index on diapers, for example, because they have a newborn. And so they would tend to buy more diapers than the rest of the other segments. All right, moving on. So missing number dot matrix, we're just going to do this again. Again, we don't see any missing values, which is good. Length customer data. So this tells us the number of rows that is present in customer data. So we have 72,636 rows. And again, we're going to check the number of unique loyalty card number. So as it turns out, it has the same number of rows. Well, it has the same number as our rows in our data, which tells us that loyalty card number is unique in every single row. So every single row represents a single customer, and every single customer has their own unique loyalty card number, which makes sense. All right, let's move on. Life stage number of uniques. How many unique life stages are there? So this particular retail store have categorized their customers in 7 unique life stages. Let's have a look at what those 7 life stages are. So these are the 7 life stages. You can have a read through yourself. And what I've done here is just a simple value counts again and see which one has, which category has, which life stages have the most most number of customers. So retirees, we have the most, and then followed by older singles and couples, and new families have the least. And what I've done here is just to create a count plot using SNS, which is Seaborn, a library that we've imported at the very beginning. So this essentially is just a visualization of this. So we see that retirees have the highest number, followed by older singles, couples, young singles, and couples. So for premium customer, we have 3 categories, and those 3 categories are mainstream, budget, and premium. So again, I've used value counts here, which will tell me which one shows up the most often. So mainstream, we have the most mainstream customers, followed by budget, and then premium is the least. Again, I've done a visualization here. All right, so what we're going to do next is, so far we have 2 data frames, right, or data set. So what we're going to do next is combine them together so that we can analyze this a little bit further. So before we do that, transaction data dot shape, this tells us the shape of the transaction data. So we have this number of rows and 10 columns. And customer data dot shape, this tells us the number of rows and then 3 columns. So what we're going to do next is use a function called pandas dot merge. So merge is going to take transaction data and it's going to merge with customer data. So this function is actually quite smart. So the way Pandas is going to merge both these data set is via a similar column that both of these data sets share. And if we can remember, both data sets have the same column called loyalty card number. So what Pandas is going to do is it's going to look through transaction data and look at the loyalty card number and match that with a corresponding information from the customer data. So I'm just going to run that cell, pd.merge, and then you pass in the 2 data frames. And then tell me the shape of this new combined data frame. So let's look at this. We have the same number of rows as the transaction data, so 246740, but we have 12 columns here, which means we have an additional 2 columns. And those 2 additional columns actually came from customer data. So the 2 additional columns is life stage and premium customers. So if we have a look at the first 5 rows of this new combined data frame, we'll see this. So date, going from date all the way to brand. So this is this came from transaction data, and as I've said before, we have 2 additional columns, so life stage and premium customers. So this came from the customer data. All right, and this is just for safety. You don't really have to do it because we've already made sure that there's no null values, but this essentially is just to check how many null values are there in every single column, and we should expect to see all zeros. So we get all zeros here. All right. So in this last section of our notebook, we're going to do some data analysis on customer segments. So from before, we've managed to merge transaction data together with customer data, and I've called that combined data. So what we're going to do now in this last section is just go through this combined data and pull out any interesting insights about our customers, so that we can go back to our client saying that, hey, we've run our analysis on your customers, and we've found out about this, this, and this. Maybe a customer segment has a preference towards a certain brand of chips. Maybe they like a certain packet size, and so on and so forth. This is for our client to formulate some sort of strategy around that. Maybe it's worth considering, stocking up on a certain brand, maybe coming up with certain promotions that push sales. Or it could be, a simple change of store layouts to encourage impulse purchase. Any of that sort of decision can come from this piece of analysis. So this is what we're going to do right now in our final piece of analysis. So in this first cell, what I've done here is I've grouped combined data based on 2 features, premium customer and life stage, and I've summed up total sales for each segment. And I've also sorted going from the highest sales down to the lowest. So if we run this, Control Enter, we can see here that the top 3 came from budget older families, mainstream young singles couples, and mainstream retirees. So these 3 segments have the most sales. And then I did a simple visualization here, which is just the same thing as the top. So I've used a stack bar plot here. So there's 7 stack bar plots here, and every single bar plot represents the life stage. And in each bar plot, there's 3 colors, each color representing the premium customers. So for example, blue in this case is budget, orange represents mainstream, and green is the premium. All right, so now we're going to push our analysis a little bit further because total sales doesn't tell the whole story. So what we're going to do next is figure out how many customers are there in each segment. And the reason for this is if a segment has more customers, that will naturally result in higher sales. So that doesn't really tell us much. But besides that, we also want to figure out what the drivers are for these sales. As you would know, total sales is driven by price and volume. So price times volume gives us total sales. So we could potentially work out maybe a certain customer segment has a preference towards a more expensive brand and hence they pay more. And as a result, we will get a higher sales. Or it could be that a customer segment tend to buy more chips. Maybe they belong to like a family, so they would tend to buy more chips in a single transaction because it's for the entire family. So this is what we're going to do next. So firstly, we're going to look at how many customers are there in each segment. So, and the way we do that is by using n unique, and we're gonna look at the loyalty card, the unique loyalty card number. And again, I've grouped my combined data based on premium customer and life stage. So this is what we get again from highest to lowest. So mainstream young singles couple has the most customer in that segment, and this is followed by some visualization. And I've left a comment here saying that there are more mainstream young singles couples and retirees. This contributes to more chip sales in these categories. However, this is not the case for budget older families. So what I mean by that is if we scroll up here, we can see that budget older families has the highest sales. But in terms of number of customers, it came in, what is this? 1, 2, 3, 4, 5. It came in 6th place, and yet it had the most sales. So an explanation for this is maybe they buy either more chips or they have a preference towards more expensive brand of chips. So we're going to move our analysis along to find the average unit that is purchased for each segment. And again, visualize this. Just a simple bar plot. So from this visualization, we can see that older families and young families tend to purchase a higher quantity of chips, which makes sense because they belong to a family, so they would buy more chips to feed their family of 4, maybe 5. So it would make sense for us to see a higher average unit for these two segments. So last but not least, we have average price. So we're going to look at whether or not each segment have a tendency to buy more expensive sort of brand. So this is what we're going to do in this final bit. So again, group my data based on premium customer and life stage. And the way you work out average price per unit is take total sales divided by the total quantity. And this is what we get. So visualize. All right. So they look about the same, but if you look closely, we can see that the orange bar for mid-age singles couples and young singles couples is actually higher than the blue and the green one for these two. So you're looking at this and this. And I've left a comment here for you to read. It's a potential explanation for this occurrence. You can read through it in your own time. But what I'm going to do next is I want to figure out if this difference is statistically significant, meaning I want to figure out whether or not mainstream actually has a higher willingness to pay than their budget and premium. So what I've done here is I've created a new feature called price. So price divides total sales with product quantity. So in this case, 6 divided by 2 gives us 3. So that, and then we put that in a new column. And what I've done here is I've created a data frame and I've called it mainstream for these two, so 1 and 2, and then non-mainstream for this, and this. So let's run the cell. And before we run our statistical test, it's always a good practice to just do a simple histogram. Just have a look at the distribution. So this is what we have. And the way you analyze this is you look at, we can see here that the blue one tends almost towards the right-hand side, meaning they have a higher average for price per unit, and they also have a higher tip. So this middle bit is actually higher than the orange one. So we would expect to see that blue has a higher mean. And the way we would confirm that is using NumPy. So NumPy has a feature called mean, so it takes the average. All you have to do is just pass in your data frame. So we're going to compare mainstream with non-mainstream. So this is what we get. So for mainstream, we get an average of 4.04. For non-mainstream, we get 3.71. So as we expect, mainstream does have higher mean than non-mainstream. So now we're going to move on to t-tests. So if you're not familiar with like statistics, t-test is essentially a statistical test which tests whether or not a mean of two distributions are different to each other. So when you're doing any sort of statistical test, it's we have to first establish a null hypothesis and an alternative hypothesis. A null hypothesis for us in this case is that mainstream and non-mainstream have the same mean, so they do not differ. And an alternative is just an opposite of our null. So if we do our t-test here, so again, I've used the function t-test, which is a library that I've imported at the very beginning. So if you use this function, t-test underscore ind, and then you pass in mainstream and non-mainstream, this is what we'll get. So with a test, you'll typically get back something called a test statistic, as well as a p-value. I'm not going to go through that in too much detail, but if you're interested, you can go have a look at Google. I'm pretty sure you can find a lot of information on that. But the way we would draw a conclusion on this is looking at the p-value. So if we were to do this in a 95% confidence, we would reject the null and say that mainstream does have a different mean than non-mainstream. Or in simple terms, mainstream have a higher tendency to buy more expensive sort of brand. So this is what I've done here. So target represents the mainstream, and non-target is just the non-mainstream. And so this very last part is looking at affinity. So affinity is just a fancy way of saying like a preference. So affinity to brand means a preference towards a certain type of brand. So we're going to run that analysis through target segment and non-target segment. So if we do this, and if we merge the two data frames together, we get something like this. So this tells us that for every single brand, target segment has this affinity, and non-target segment has this affinity. And then we're going to go ahead and create a new column, which takes this value divided by this value. So what that means is if affinity to brand is higher than 1, tells us that target segment has a preference towards this brand than non-target segment. So as we can see here, Terrell's has the highest affinity to brand. And so I've left a little comment here saying that mainstream young singles couples are more likely to purchase Terrell's brand compared to other brands. All right, so now we're going to do the same to pack size. So affinity to pack size is essentially just the same thing, but we're applying it to the feature pack size. So I'm not going to go through too much detail. You can run through this. So this is what we get. Again, create a new column, which takes target pack affinity divided by non-target pack affinity. If greater than 1, tells us that target segment has a preference towards that particular pack size. And for us in this case, target segment prefers the pack size of 270 the most than the rest of the pack size. And then I've also left a comment here. It looks like mainstream singles couples are more likely to purchase 270 gram pack size compared to other pack sizes. All right, so we want to work out which brand offers 270 pack size. So again, recall our log function. So tell me which row has pack size equal to 270 and show me all the columns. And I want the first 10 rows of the data. And this is what we have. So notice how product name, under product name, we can see, twisty cheese, twisty chicken, twisty cheese. They all seem to be from the brand Twisties. So we want to see if that is true. And the way we do that is using .unique. So give me the unique brand that offers 270 pack size. So as we can see here, Twisties is the only brand. All right, and that is the end of the video. I hope you enjoyed it. This notebook actually took me a very, very long time. So if you don't mind, drop a like if you found it useful at all. And definitely share it with the people that you know learning data science and machine learning. I'm still in the process of learning myself, so I know how useful and valuable these resources are. So feel free to share my video around. I know it's quite a technical video, But if you would like me to run through some tutorials, I'm considering doing that. So let me know in the comment section, or you can shoot me a message. I highly recommend you guys have a go at the project yourself. So again, visit InsideSherpa.com, visit Quantium, and then that's where you can find the data, load the data, and then do your own piece of analysis. By no means is my notebook an exhaustive or comprehensive analysis. It's just a skeleton for you to build upon it using your own knowledge. And if there's any way you see that I can improve in my notebook, do let me know. Yeah, have a goal, have fun with it. Once you submit that project, you'll get a sample solution, but it's in R. So if you prefer to code or program using R, feel free to do that. But my notebook is in Python. But anyway, I think I've said all I wanted to say. Take care, and I'll see you in the next video.